Hi gents, I'm here again for moments and I'm starting question D on page 67, which is that question right there, okay? And we're going to have a look at finding the moments around D. So again, before we get started, just remembering clockwise motion, positive figure, anti-clockwise, negative figure, okay? So let's have a little look at our problem. I've done it on a piece of paper again so we can have a look. So right now we have two distances. We have a 50 millimeters in a horizontal direction distance. We also have a vertical distance at 360 mil. And then we have one force. Now that one force is on an angle of 50 degrees and it's 250 newtons. Okay. So what have we learned from the question from C when we did our angled force before? We talked about this, and we talked about how that's on an angle, and we could be finding a force vertical or a force horizontal depending on our distance direction. Now, as we talked about before, a vertical distance, which was the one above on question C, gave us a force horizontal. A horizontal distance gave us a force vertical. Now if we go down to our problem in D, our problem in D gives us two directions. It gives us a horizontal distance and also a vertical distance. So it's essentially telling us that because this force is an angled force and we have two distances, we have to find a force horizontal and force vertical to find the moments around D. So let's have a little go at this problem. So this formula would again be moments around D, yeah, with our positive symbol, okay, equals, now we have two distances and we still have that one force which can act as a force vertical and a force horizontal. So we might put this in a bracket and we got force, which we do, multiplied by the distance plus, okay, because we have another distance, we need to do force multiplied by the distance. So we have 2. Okay. So this is what that would look like then. So we have our equals. So we do our first one, which is force. So it'd be 250. Now we got our formulas up here. So our horizontal was cos angle. So we can add in our cos. Our angle's 50. Okay. Multiplied by our distance. Now what did we say up here? We said if we have a horizontal distance, we're looking for a force vertical. If we have a vertical distance, we're looking for a force horizontal. So we've written force horizontal, so we need to use the vertical distance. So that would be 250 newtons, cos 50, which gives us that force horizontal formula. That's 360 millimeters, so we need to convert that. So that needs to be 0.36, close the bracket, plus, and we'll start our other bracket down here, so we don't run out of room. Using that again, 250, this time sine, our angle is still 50, multiplied by, now we said before, okay, we're using, down here we're using a force vertical formula, so force vertical, horizontal distance, good, so that's the 50 mil. So that 50 millimeters needs to get converted to meters too, which is 0.05. Okay, so that there would be our formula to find the force on this. Okay, now something I didn't mention was that arrow is, yes, pushing in a clockwise motion. Okay, so yes, both of these are still positives because that is a clockwise motion. And I probably should have said that at the start, but I'm hoping by now we understand that concept. So we want to find the equals. Now the answer for this is 67.4, and yes, if you want to go to a second decimal point you can, Newton meters, and that's a positive answer. So we need to add in our positive symbol. Okay. So that there, gents, is the answer for D. Thank you.